Hey everyone, welcome back to Algebra 1, where we're going to be discussing solving compound inequalities involving and or. So we're going to start with defining what a compound inequality is. And a compound inequality is where there are two simple inequalities that are combined by the words and or. So let me highlight that really quick. And or. Those are going to be common themes in today's video. So I have here a little graph to show really quick a few examples of what we're going to see. So you're going to see in the first column where it's stated, written out, then the algebra version of it, and then we're going to graph it. So for the first example, we're going to go over where we have something that says all real numbers greater than 2 and less than 6. Keyword, and. That's going to be represented by writing in algebraic form x greater than 2, because that represents over here all real numbers greater than 2, and then you put and less than 6. X is less than 6. I have underneath here another way you can find it. For the and situations, you can write it two ways, and it's important that you know it. This one is a more combined way. When you see this, you have to connect that this is saying that x is less than 2. I mean, x is greater than 2, and all values of x that are less than 6. So when we want to graph that, it's important to look at a couple things. Let's start, we're going to divide and conquer. So we have the first part, which is x is greater than 2. So let's see, we're going to do green. You have an open circle. And then your numbers are going to go this way. Oh. And then it goes up to 6 though. And it's like that. And I'll highlight to show what it's going to be. Alrighty. The second example we're going to go over is where it can say something like all real numbers are greater than or equal to 2 and less than and equal to 2. Very similar to the first one, but instead of just greater than, it's greater than or equal to, and we're talking about less than or equal to. So the signs over here are going to be greater than or equal to and less than or equal to, according specifically to what this is saying. And I have underneath it the combined version that, again, we have to know the difference of. It's still a version of and, though. And then a graphed version of it is, we're going to see that whenever it's equal to involved, the circle is enclosed. And I'll highlight that. Third example is all real numbers are less than 2. Now this is different. It says or greater than 6. Revealed algebraically, when we write it down, this is how it's going to look. X is less than 2, or it's greater than 6. Let me highlight a few things here. This time we're talking about or. And when we graph it, it's an open circle because it's less than, and it doesn't have equal in it. And then the graph goes this way to follow what it's saying. And then for the second part of the or combo, x is going to be greater than 6. So at 6, I'm going to make an open circle and then make the arrow go that way. So when highlighted, both of these, let's do a different color, are involved, but they're both open circled. Last example is when we have an example where it says all real numbers less than or equal to 2 or greater than or equal to 6. Again, we have or involved. Algebraically, it's written like this, where we have x is less than or equal to 2 or x is greater than or equal to 6. We should then be able to see that when we have to graph it, the circle at 2 is going to be filled in. And since it's less than, it's going to go to the left. And then at 6, it's also going to be filled in, but since it's greater than, it's going to go to the right. Now, mind you, this is just a few examples. Sometimes you will have where it'll be x is less than or equal to 2 or x is greater than 6. In that case, this one right here would be circled in. So they're not always going to be hollow dot in one example and then filled in dot, filled dot. Sometimes you're going to have a hollow dot and then a filled in dot, which you'll see in a couple examples as we go on. So this was just to show you in a somewhat summarized way some examples that you can expect. And for the or situation, there's only one way to write it, as opposed to and, where you can have it separate like you have in or you can do a shorthand. And you'll see how that is handy when you go to solve a problem. So when we are talking about solving compound inequalities involving and, there's a strategy that I like to follow. And that is first, isolate the variable, which we're familiar with from past videos. We're going to solve, and then we need to know how to graph the solution, which we're going to go over here. So we're going to do this problem that I have here as an example. So we have 4 is less than or equal to x plus 2, which is less than and equal to 8. Remember, when it's like this, we're saying this is an and example. 4 is less than or equal to x plus 2, and x plus 2 is less than or equal to 8. Now I need to isolate the variable. So the variable here in the middle is a plus 2. I'm going to minus 2. So whatever I do here, I have to do to this side, and I have to do to the other side. That's going to give me 2, which is less than x, which is less than 6. This is my answer. Now, I'm also going to do the other shorthand. So we're familiar with both. We can write x is greater than or equal to 2. And x is less than or equal to 6. These two are saying the same thing in different ways, and they're both correct. So we've done the first part, which is isolate and solve. Now we need to know how to graph. When we are new at this, we need to graph everything individually. So I'm going to start with x is greater than or equal to 2. And I'm going to start up here. So let's say we have 0 here, 2 here, 4, 6, 8. We have greater than, x is greater than or equal to, so that means we have a hollow circle. So we'll start at 2. And then everything is going to be going this way. Now for the second one, x x is less than or equal to 6, we have to graph as well. So 0, 2, 4, 6, 8. We have 6 here, and since it's less than or equal to, we know it's a hollow circle. I mean a filled in circle, and everything to the left satisfies this answer. Okay, so those are the separate ones, but when we are doing a combo involving and we'll see later with or, we have to make sure everything accounts for. So what we're going to do is we're going to look at the combined effect, and everything that overlaps we're going to make sure is accounted for here. And this was 0, 2, 4, 6, 8. That is our answer for this particular solution. I'm going to highlight it so that one side was going this way, one side was going that way. The combined answer for both is the part that overlaps. That overlap is called a union, which I will write out here. Union is the overlapping region that represents the solution. Okay. We're going to practice one more time. So in this one, we have an example of -5 is less than or equal to 2x plus 3, which is less than or equal to 9. Restated again, we can say that -5 is less than or equal to 2x plus 3, and 2x plus 3 is less than 9. I want to first isolate the variable. So I have plus 3 here. I need to minus 3. So I'm going to minus 3 on this side and minus 3 on this side to get rid of that. And then I have -8 is less than or equal to 2x. 6, then I'm going to divide by 2, both sides. So then I have -4 is less than or equal to x, which is less than or equal to 3. That, and then restated a different way, I can put that x is greater than or equal to -4, and x is less than 3. So I'm going to graph this one here. So I have x is greater than or equal to -4. So -4 is around here, and it is greater than or equal to, so this is going to be a hollow circle. I mean, not hollow, it's going to be a filled-in circle. And it's anything that's greater than that. So we're going to make sure this is highlighted. Okay, then for the second one, we have x is less than 3. So 3 is around here, and it's just less than, so it is a hollowed circle. And all the values less than 3 satisfy this part. So we're going to do this. Now we're going to look for the union, because in this case, it is an and situation, and and situations have unions. And we're just going to copy this part, copy that part, and this is the actual graph for the and version of this solution, and I will highlight that. Okay, now moving to the next topic is I want you to realize that sometimes you're going to have to work backwards, and instead of giving an algebraic version of it, like here in this first graph, the algebraic version of it, you maybe just be given a graph, and they want you to find out what this is saying. Now, since there is a union highlighted, we know that this is going to be an and situation. So we're going to just start at one side. So let's start on the left side where we have a filled in circle at 0. So then we know that its x is less than and equal to 0. Then we're going to put and. At the other side, we have a filled in circle, and it's between 6 and 8. So we're going to say 7. And it looks like that's the highest value. So x is going to be less than or equal to 7. We can write it this way, but I want you guys to get comfortable writing it both ways. So then we have 0 is less than or equal to x, which is less than or equal to 7. I mean, this was greater than equal to. Sorry, guys. This is actually greater than. Okay. Let's go to the next one. So this one now is going to be solving compound inequalities involving or. The first one we talked about was and this is or. Same strategy is involved. We're going to isolate the variable, solve, and then we're going to graph. Know how to graph the solution. So we have an example of -4 plus x is greater than 1, or -4 plus x is less than 3. Isolate the variable. We have a +4, -4, so we're going to do +4 on both sides, +4. And then or, then we're going to do this one +4, so +4 on both sides, x is greater than 1. First graph, we're going to have 5, and it is just greater than, so it's going to be a hollow circle, so 5 is here, and x is going to be larger than those. So we're going to do that. For the second one, we have x is less than 1. So we're going to look for 1, and it's a hollow circle because it's not equal to. And then every value that makes that right is over on this side. We're going to highlight. Now here you'll see that there's no overlapping. If we were to do individual lines here, dash lines up and down these three, there's no overlapping. So the actual answer is we just rewrite what we see. So here we have this going that way and this going that way. And that's our answer for or, and that's how the graph will look typically for or. There's going to be a space where there are no solutions, and then the solutions are flanked on the opposite sides of that space, as you'll see here in this graph. And have an overlapping section called a union. The ors do not have an overlapping section. Okay? And then working backwards, same example, I want y'all to be familiar with how to do that. And in this case, we have a graph starting, and we need to figure out what the algebraic form of this looks like. So we're just going to start from one side, and then we have what looks like a -1, and it's a hollow circle. So it's going to be either less than or equal to or greater than or equal to. And this one looks like it is, let's put -1. X, and is that greater than or equal to? Looks like it's going to be less than x is less than or equal to 1, and then we'll put or, because we see that there's no union. There's actually 2 parts length outside of a part that doesn't have solutions. And then we have here, we'll put x. This also is a hollowed circle, so we know there's an equal sign, but the value is between 6 and 7, so it's 8. And it looks like it's going to be x is any value greater than or equal to 7. Follow me to go practice these problems in the videos that are linked in the description of this video. I'll do one on easy examples and I'll do one on some difficult ones. See y'all next time.